Ladies and gentlemen, welcome back for another round. This is Mr. Doolin, and I thank you so much for tuning in. Today we're going to be talking about measurements, ladies and gents. Now, one thing to understand is that measurements happen all around us, every second of every single day. Think about this. The last time you walk through a grocery store, you pick up any kind of container, you look at it, and the amount of food that is in the container has been very specifically measured and put in there. And then you turn the container around, and guess what? It's got a nutrition label on that dang thing, and the nutrients inside of the food that's inside of the container have actually been measured, and you'll list and see all those measurements on that nutrients label. Things like sugars and carbohydrates and fats and those types of things. When's the last time you put on a pair of shoes or went to go buy a pair of shoes? Well, Nike and everybody else, Adidas, understands that when they make those shoes, they have to measure all those things that they're making. They have to put out a shoe that is of a specific size so that you know which one to buy when you actually go and buy your shoes. One type of measurement that happens and is all around us is types of medicines, right? Think about the millions and millions and millions of people that are on this planet that actually depend on those measurements being very, very accurate and very, very precise, right? Their life depends on it a lot of time. And so these are just a few of the thousands of different types of measurements we come across every day. And we can go example after example after example. But I want to pose this question to you, and this is really where we're starting and where we're going to go today. Have you ever wondered whether or not you have confidence in those measurements and whether or not you actually trust them? So hopefully by the end of the lecture, as we go through this today, we're going to be looking at where that confidence in measurements actually comes from. Right? Why do we tend to trust those numbers, and where does that confidence originate from when the measurement is actually being taken? Right? Then we'll look at how to properly take those measurements so we can maintain that confidence and report it to others. We'll take a look at the types of errors that show up when we're actually going to be taking measurements, and more importantly, probably we'll look at how to avoid some of the more common ones. And then by the end of the lecture, we'll run through, or to tie everything off at the end, we'll look at some common units that we'll run across this year when we're actually taking our measurements and we're doing our labs and doing our practice problems. So one of the first things we are actually going to take a look at here is our confidence in our measurements. So I'm going to pose you a question here. If you took a 200 milligram ibuprofen tablet, is it really 200 milligrams? Are you sure that it's 200 milligrams that you're getting there, right? Have you ever really thought about that? And hopefully by the end of this lecture, you'll start to kind of question numbers like 200. And definitely by the end of next week, you'll really have a different insight into how significant is that 200 number to people, and what does it really have in terms of its meanings and its level of confidence. And to kind of give you an easier, less threatening, I guess, example for that is if you went to a gas station and you bought 20 gallons of gas. My question for you is, did you get 20 gallons or did you get 15 gallons of gas? Because, I mean, technically, if we look at this, doesn't 15 actually round to 20? Aren't those the same number, depending on how they're rounded? And that's where we start to kind of look, right? 15 could be 20 in some situations. They're actually going to be the same number, depending on how those measurements were actually taken. And so now I run back to this very initial example that's on this page. Is that 200 milligrams really 200 milligrams? And so that's really why we're trying to take this, right? Where is the confidence level in those measurements? Is it 15 or is it 20? Is it somewhere in between? Is it 200? Is it 240? Is it 175? Right? And so the confidence in our measurements has to be reported in a way so that we can have confidence in our original measurement, and also the people that are looking at our measurements can have that same level of confidence that we had when we were taking our initial measurement in the first place. So what we're going to do now, if we're really talking about confidence in measurements, it's actually time to introduce precision and accuracy. So precision and accuracy, let's go ahead and take the technical definitions here. I'm actually going to summarize the technical definitions. So precision is actually representation of the number of digits given in a measurement. And here's what I mean by that. If I'm looking at a number that's 28 versus a number that is 28.0, you understand 28.0 actually has more digits in that number. 28.0 would have a higher level of precision than just 28. Another example of that would be like if I'm looking at 0.01 versus something that's 0.0123. Right? Again, 0.0123 has more digits in that number, and so it would have a higher level of precision. And so when we're looking at the precision, the greater the number of digits, the greater the precision of the number. Now, when we're looking at accuracy, the summary of the technical definition of accuracy is that it means the measurement conforms to the correct value or a standard known value. And so I want you to stop and look here for just a second and take a look at these definitions. Are they the same or are they different? Because a lot of people use precision and accuracy interchangeably. But hopefully if you're looking at their definitions, you understand they are two very different things. And so the question I pose to you now is which one of these will actually provide confidence in our measurements and actually express that confidence to others? Could you take a guess? Well, most people say that accuracy actually provides most of our confidence, but they would be wrong. Most of our confidence in measurements actually comes from precision. And if you use common sense and really stop to think about this, right? With precision, we can control how many digits we can record and report based on the equipment that we use. Accuracy, when we're actually taking our measurements, we have no idea whether that measurement is actually correct or not correct because we'd have to go through the process of actually comparing it to a known or standard value. And a lot of the times when we're taking measurements, we just don't know what those values are. And so hopefully that clears up confusions between what precision and what accuracy are, and also allows you to understand, if we're talking about in this lecture confidence in our measurements, that a lot of what we're going to be talking about moving forward is actually precision. So check it in before we move on, ladies and gents. I want you to pause the video and I want you to answer these questions. And believe it or not, if you answer these questions out loud without reading the notes that you've already written down, it will help you far more than if you actually just read these and go back and read the definitions inside of your notes. All right, so pause the video, get these things, I guess, orally answered in your own room or wherever you're at watching this lecture, and then unpause the video and we'll move on. All right, so now we're back, ladies and gents, and we're talking about precision. Now, one thing I want to point out right from the very get-go is that precision is determined by increments. And the smaller the increments are, the higher the precision is actually going to be. And so now some of y'all are asking the question, wait a minute, Mr. Dillon, what actually is an increment? An increment is the smallest change that is marked on a piece of equipment or the smallest decimal place displayed on an electronic piece of equipment that we're using to measure something. And so I want to make sure that you know how to actually determine what the increment of a particular piece of equipment is. And so I've just drawn a cylinder over here on the left-hand side of the page, and let's take a look at what we've got going on here. So I see that my major markings on this piece of equipment are 0 and 10. Right? And then I'm looking, right? Because remember, it's the an increment is the smallest change marked. So I'm looking at all of these markings, the smallest ones, the smallest increment of change. So I see going from 0 to 10, I've divided that into 10 different things. And so what I've got here is my major change is 10, and then I've got 10 markings in between there. So if I divide that out, my increments in that particular case are actually 1. A lot of people aren't going to do the math on that, and they're actually just going to count it. Right? If I'm going from 0 to 10 and I'm just bouncing on these marks, what do I have to count by to actually get from 0 to 10? And you'll notice it's just 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so the increments on this particular piece of equipment would be 1. Another example that I've drawn over here on the right-hand side, again, we have a cylinder here. We've got major markings going 0 to 1, and I'm not going to do the math on this. I'm actually just going to count it on through. And so I'm going to go 0. And what do I have to count from to jump on these marks to get here? So 0, and then this is weird. It goes 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then actually get to 1. So in this particular case, the increments are 0.1. And believe it or not, the reason I chose these two examples, ladies and gents, is 0.1 and 1 are going to be your most common type of increments that you're going to run across on the glassware and the equipment that we actually use in our laboratory equipment in class. So now what we want to do, ladies and gents, is we want to go through a couple of examples where we use increments to actually make our measurements and record our value. So the first thing that we're going to look at is taking measurements when we're measuring volume. So I've got two different types of glassware listed here. On the left, I've got a graduated cylinder, and over on the right-hand side, I've got a beaker. Now, both of these we can actually use to measure volume, but I want to start taking a look at something, right? I've got this as just a blow-up of that particular graduated cylinder so we can look, and notice I go from 0 to 10, because the very first thing you want to do when you get a particular piece of glassware is check and see what the increments actually are. And you'll notice we go 0, and then I've got 10 markings. I know they're kind of hard to see. if I line them up and make them light, it'll make that a little bit easier for you guys to see. And you'll see, we just saw an example of this where we're going from 0 to 10. There's 10 markings in between. So the increments on this particular piece of glassware are 1. And in this particular case, it's measured in milliliters, so I'm going to go ahead and put milliliters up there. Now let's go over to the beaker. Now for the beaker, what you'll look at is I'm going to look at this right-hand side over here, right? You'll know this is when the numbers read from bottom to top and they're increasing from the bottom to the top, that's when you're actually adding liquid to the container to actually measure. If you look on the left-hand side over here where I'm going from 0 to 100, 200, 300, 400 down, normally what that is you'll actually put some kind of liquid into the beaker and then you'll pour some out and you can actually measure how much you poured out. So most of the time if we're taking measurements, we're actually going to be using this right-hand side. And so if you look here, I'm looking at from 100 to 200, there's only 1 mark in between there. So the increments on here, I'll actually abbreviate that, is actually 50 milliliters. And so let's go ahead and see how we use increments to actually take our readings. So in this particular case, I see the bottom of this meniscus, right? And this is a meniscus. Water in your graduated cylinders will actually form this kind of oval dipped shape, almost like a smiley face. And that smiley face is called a meniscus. Now, when we read a meniscus, we read the bottom of the meniscus. So make sure you get that written down, what a meniscus is and how you actually read the meniscus. We always read the bottom. So in this particular case, you'll notice that it lines up right here very nicely between, or right here on this mark here. Let me get that orange color again. So we're right here, right? Whatever that mark is, that's what our reading is actually going to be. So I'm going to go 0, 1, 2, 3, 4, 5, and then that's going to be 6. And so my reading on this, what I put 6, I'm not going to put 6, I'm actually going to put 6.0. Because again, think about it. If for some reason this value was like right in the middle, we would actually be able to estimate between that, I guess that would be 0 and then 1 and 2. We'd be able to estimate between 1 and 2 to a decimal place, right? And so what we need to do is, again, we are confident that this is right on 6. So we don't want to put 6, we want to put 6.0. And so a general rule of thumb is that you always go 1 decimal place past where your smallest increment is. And that rule works very well when you have increments of 1 and 0.1. Now, if we go and look over on the right-hand side for the beaker, I'm actually looking here, and again, it's right here. It's right above the 400. So the 400 mark is here. Now, I'm not going to go 1 more decimal place, but I'm actually going to kind of figure out, because you have to use common sense, like how could I break down the difference between like 150 and 200 and be still pretty confident about that number. So I know that this meniscus is above 400, but it's not quite halfway there. And so I'm probably going to say that that's somewhere around probably 410 or 420. And notice I'm not real confident about whether it's 410 or 420. So I can't say like 415 because I would be absolutely guessing at that last digit of 5. So I'm probably going to put 410 milliliters over here. So now here's my question. Which one of these numbers is more precise? Because up to this point, you'd say more digits, right? And 410 has more digits than 6.0, but what I need you to understand is we're looking at digits after the decimal place, right? And so in this particular case, this would be more precise. And so again, with confidence, think about all the measurements that we make and the confidence that we want to have. If I want to measure volume and I want to be confident about that measurement, would I choose to measure it with a beaker with increments of 50 milliliters, or would I choose an increment of 1 and use a graduated cylinder? Well, I would use this all day long, right, over a beaker. And so again, think about that when we're measuring things, we want that precision to be higher. Smaller increments leads to a higher level of precision. And then also keep in mind that we can always, once we determine what our increments are, we can always estimate between those increments, all right? And that's where we get our final, that last little estimation piece, this 0.0 here, right? That's what we're kind of uncertain about. It could be 0.1 or somewhere between that, but the last digit in there is going to contain just a little bit of uncertainty, right? So we always use our increments to figure out what decimal place we're going to record to. And so again, ladies and gents, before we move on, I definitely just wanted to put this on its own piece of paper, or own sheet here, or own whiteboard, whatever you want to call it I'm writing on. All right, but you need to understand that smaller increments will lead to higher amounts of precision that will give us more confidence in our measurements. So if you have a choice, again, about which type of glassware or which piece of equipment to use, right, you just have to understand smaller increments will give you more confidence in your measurement and will allow people to trust that measurement that you've made more. All right, again, ladies and gents, before we actually switch gears here and move on in topics, just check in. And again, go ahead and read through these questions. Pause the video. Make sure that you can answer them. Answering them out loud or orally is awesome, awesome, awesome. It really cements that information into your brain. And this is one of those times, ladies and gents, is if there's something here that you can't actually answer, you may want to go back and rewatch this last section of the video to try and get this information down before you come to class. All right, so now what we're going to do, ladies and gents, is we're going to move on to the three and discuss the three main types of errors that we're going to run across in this class and just science in general as well. All right, I'm not going to write the definitions on the screen here, but you definitely probably want to jot a couple of things down. So the first type of error that we can run across is called a systematic error. Now, systematic errors actually can be identified because what's going to happen is that all of our values will be wrong in the same direction by the same amount. And this kind of error can happen, for example, if we're using a thermometer to measure temperatures and our thermometer is actually calibrated to be 2 degrees too high on accident. And what we'll do is we'll figure out, all right, well, all of our temperature readings are 2 degrees too high, so we can actually account and just subtract out the 2 degrees, and then we'll be back to what we would actually call an accurate value for our temperatures. All right? The next type of error is called a random error. Now, random errors are really hard to identify. They're fluctuations that affect a small number of measurements in a random fashion. Now, these types of errors you can control in your technique normally the way you approach the lab. For example, if there's 10 different electronic balances in the lab and you're going to be weighing things, only use one balance and use that one balance for the entirety of the lab. And what that does is it gets rid of the errors because, for example, if you're using all 10 different types of electronic balances there and one of them is not calibrated correctly and you never know which one it is, then when you look at your data, it'll be really hard to identify where that random error occurred and actually correct it. The last type of error is actually called a blunder. Now, a blunder is an outright mistake by the user itself, all right? And these are going to stick out and they're going to be easily identified. For example, I'm the teacher. I know how to read increments and I know how you should read glassware. If you're taking measurements on glassware and I know what the increments are, I can look at your readings, and if you haven't reported your readings to the proper decimal place, I will know and be able to spot that immediately. It will stick out like a sore thumb, right? And that's probably what we're actually going to, and where most students in this class, in this level of chemistry, are going to make their errors, right? And the blunders, these are the ones that you're going to be held responsible for eliminating. And the most common type of blunder that again will occur is this: you're not going to record to the proper decimal place when you're reading equipment. So really pay attention to those increments every time you're going to take a measurement from a piece of equipment. All right, now to tie this lecture up, ladies and gents, we're going to go through just some common units that you're going to see on the equipment that we'll use to measure and use in our labs this year. Mass, most of the time your balances are actually going to read in grams, and that's what we want to report in, right? We're going to be using the metric system in chemistry, so our mass is going to be in grams. Our temperature, most of our thermometers actually are going to read in Celsius. Even though the standard unit of measurement for temperature is Kelvin, most of our thermometers that we're going to use in this class read in Celsius, and I'll teach you how to do the conversion there to actually get it to Kelvin if you need to. Distance is going to be in meters. Volume, this is going to be in milliliters most of the time, right? We do have some equipment that reads in liters, but most of our graduated cylinders and most of our beakers actually read in milliliters because we work at such a small scale. All right, time, this is going to be seconds. And then amount, this is one that you've probably, right? Most of you are familiar with these top 5, but amount, this is actually going to be a word called mole, like the animal, but not really the animal. This is an amount. And this is something that I want to introduce early on. We're a couple of days into chemistry at this point, ladies and gents, and we're already going to talk about one of the most important types of units that we're going to run across throughout the year, and just get that in your head. It's a mole. It's an amount, right? Like the word dozen means 12. Mole means an amount of a substance. If I say I have a mole of calculators, I'm telling you how many calculators I have, and we'll get into what the number actually is later on another time. All right? So no need to memorize this list, ladies and gents. Probably throughout the course, it's going to become second nature because you'll start seeing these things over and over and over and over and over again. And I just wanted to get the units out there early so we can start taking kind of recognizes when we start seeing them and run across them. All right, so here we go, ladies and gents, that last check-in that we're going to see here. Make sure you pause this video before you turn it off and close your notebook. Make sure you can get these questions down, and if you can't, you might want to go back and again rewatch this last section of the lecture and make sure that you have this ready to go by the time you come to class, all right?